Number 13, indicate what type or types of reaction each of the following represents. And then we have letter A. So in this equation, we have a calcium, that's a solid, plus bromine, which is a diatomic, there's two of them, and that's in a liquid form, will yield calcium bromide, CaBr2, and that's a solid. Okay, so in order to answer this question, we have to see what's going on here, right? I'm going to represent calcium as being this blue circle, and bromine is going to be this yellow circle, right? So what basically is happening here is that we have two separate things, right? We have calcium, which is in its elemental form, and bromine, which is in its, most simplified form. Remember, bromine is one of your diatomics. And together, they came together to make a new compound. And it's only one compound. So basically what happened is we took the calcium, and actually what I'm going to do is I'm just going to make a new one, boop. And we took the bromine, boop, and we combined them together. Now, technically, you can, there it is. Look at that nice color change. Do you see how we made green from these two things, right? And what happened? You took these two things together and you made this new compound, CaBr2. You produced this new compound. You formed this new compound. Whenever you have one element that's in its elemental form mixed with something else, and they come together as one single compound, you formed that one single compound. This is called a formation reaction. Oh, yeah. So that's the basis of a formation reaction. Formation reactions are when you have one single thing, A, in this case it was just calcium, one single element, right? In this case it's in its diatomic state, but we represent it as B, and then they come together to form one single compound. This is a formation reaction. This reaction can also be called a addition reaction. Usually I call it formation reaction, but you can maybe see it as an addition reaction as well. Now, let's see, are there any other types of reactions for this one? Yeah, there's one other one, and this has to deal with charges. So just be on the lookout to see what types of charges your compounds have, okay? So remember that any element by itself in its natural state, so maybe I'll just erase this for now. Any element in its natural state, so calcium, and I don't see a charge up here, right? Bromine, I don't see a charge anywhere. Elements that are by themselves have charges of 0. Once you put an element in the compound, they automatically have charges. And we know how to make CaBr2, right? If we just write out CaBr2, remember, we can just crisscross back up to find the charges. This 2 down here told me that calcium was a 2+, and calcium is in group 2, so it is a 2+. There's one calcium down here, so bromine would be a -1. Remember, positives in the front, negatives in the back. So it looks like these changed charges. They changed oxidation states. Calcium went from being a 0 to a +2, and bromine went from a 0 to a -1. Anytime you change a charge for a single element, it is automatically called also an oxidation-reduction reaction. So in this case, you have two answers. Addition reaction, which AKA is a formation reaction, whichever one you want to say, and it's an oxidation-reduction reaction because you have these change in states. And we will get into oxidation-reduction way later in this chapter, so just stay tuned. But just know that if you can spot out a change in the charge, it's an oxidation reduction. And you'll see that a lot in this chapter. And in reactions in general, most of them are oxidation reduction. Okay? So guys, thanks for tuning in. Hopefully this helped. Let me know in the comments what you thought, and if it did help you, give it a thumbs up. But yeah, if you want to subscribe to the channel, that would be fine too. But if not, just subscribe. Thank you. I will see you guys all in the next lesson. Good luck on those tests, okay? Bye-bye.